However, there are some alternative form for the equation of a circle, which is x squared plus y squared plus 2f of x plus 2gy plus c equals to 0. And you will see that this actually came from the first form that we have looked at, which is x minus a squared plus y minus b squared and equals to r squared. And this is called the complete square form. So we'll try to get rid of the brackets. So we get that x squared minus 2ax plus a squared plus y squared minus 2b. You will see that it equals to x squared plus y squared minus 2ax minus 2by plus b squared plus a squared minus r squared equals to 0. And you will let the last three terms to equal to c. So you will write it finally in the form x squared plus y squared plus 2f of x plus 2gy plus c equals to 0. Let's look at an example in which we have to find the center and the radius of the circle with the equation x squared plus y squared minus 14x plus 16y minus 12 equals to 0. So first of all, we would rearrange it into the completed square form. So firstly, we will group all the x with x and y with y, and then we will complete the square, which is x minus 7 squared minus 49 plus y plus 8 squared minus 64, and don't forget the last term, which is minus 12. And at last, you end up with x minus 7 squared plus 8 squared equals to 125. So the center is 7 and negative 8, and the radius is square root of 125. And you know that 125 can be found by multiplying 5 and 25. So square root of 25 is 5, so the radius is 5 square root of 5. You can use algebra to find the coordinates of intersection of a straight line and a circle. A straight line can intersect a circle once, which is basically the tangent, and twice, or not at all. Let's look at an example in which we have to show that the line y equals to x minus 7 does not meet the circle x plus 2 squared plus y squared equals to 33. So the equation of the line is y equals to x minus 7. It actually shows the value of y, so we can substitute this into the equation of the circle. So it would be x plus 2 squared plus x minus 7 squared equals to 33. And you need to factorize out the brackets. And you get that 2x squared minus 10x plus 20 equals to 0. Then divide both sides by 2. So x squared minus 5x plus 10 equals to 0. And you can use the discriminant to see if this equation actually makes sense. So 25 minus 40 equals to negative 15. So b squared minus 40c is smaller than 0. So there are no real roots, and the line and the circle does not meet. And you can use the properties of tangents and chords within circles to solve geometric problems. A tangent to a circle is a straight line that intersects the circle at only one point. A tangent to a circle is perpendicular to the radius of the circle at the point of intersection. Let's look at what it means. And so basically, the red line is a tangent and the blue line is a radius, and they are perpendicular to each other. And a chord is a line segment that joins 2 points on the circumference of a circle. The perpendicular bisector of a chord will go through the center of a circle. The blue line is a chord, and the red line is a perpendicular bisector, and the perpendicular bisector will bisect the chord into two equal lengths, and they are also perpendicular to each other. Let's look at an example in which the circle C has equation x minus 2 squared plus y minus 6 squared equals to 100, and it asks us to find an equation for the tangent to C at a point tan 0, and we have to leave our answers in the form ax plus by plus c equals to 0. First of all, we know that the center of the circle C is 2, 6, and we're trying to find the gradient of the line between the circle center 2, 6 and the point tan 0. So 6 minus 0 divided by 2 minus 10 equals 2. 6 divided by negative 8 and equals to negative 3 over 4. So a line perpendicular to it is its tangent and is 4 over 3, as they need to multiply and give negative 1. So the equation of the tangent is y equals to 4 over 3 times x minus 10, and you will end up with 4x minus 3y minus 40 equals to 0. A triangle consists of 3 points called vertices. It is always possible to draw a unique circle through the 3 vertices of any triangle, and the circle of the triangle is called circumcircle, and the center of the circle is called circumcenter of the triangle, and is the point where the perpendicular bisectors of each side intersect. You might have already known that for a right angle triangle, the hypotenuse of the triangle is the diameter of the circumcircle. If you want to write the proof, you can say that the angle in a semicircle is always a right angle. And in order to find the center of a circle given any 3 points on the circumference, you can find the equations of the perpendicular bisectors of 2 different chords, then find the coordinates of the point of intersection of the perpendicular bisector. Since you know that the perpendicular bisectors will meet at the center of the circle, let's look at an example in which the point P, 3, 16, Q, 11, 12, and R, negative 7 and 6 lie on the circumference of the circle, and the equation of the perpendicular bisector of PQ is y equals to 2x. And it asks us to find the equation of the circle. So first of all, we will find the perpendicular bisector of another line, either PR or PQ. When you know the perpendicular bisector, you can find the center of the circle by finding the point that they meet. When you know the center of the circle and one point on its circumference of the circle, which is given in the question, you can come up with the equation of the circle. And firstly, we're going to find the perpendicular bisector of PR or PQ, and in this case, we'll go with PR. And in order to do that, we're going to find the midpoint of PR first. So 3 plus negative 7 divided by 2 is negative 2, and 2 plus 16 divided by 2 is 11. Then you'll try to come up with the gradient of PR, which is y2 minus y1 over x2 minus x1, and it's 6 minus 16 divided by negative 7 minus 3, which is 1. So a line perpendicular to it is negative 1. Therefore, the equation of the line perpendicular to PR is y equals to negative x plus 9. And as we mentioned at the start of this question, then we're going to find the center of the circle, and is the point where these two perpendicular bisector meets. So from the question, we get that the equation of a perpendicular bisector of PQ is y equals to 2x, and what we just found before, the perpendicular bisector of PR is y equals to negative x plus 9. So in order to find the intersection of these two lines, we would equate them. So 2x equals to negative x plus 9, since they all equal to y, and 3x equals to 9, so x equals 3. Then substitute the value of 3 into y equals to 2x or y equals to negative x plus 9, and we get that y equals to 6. So the circle center is 3, 6. Now we know the center of the circle, and the last thing that we're missing is the length of its radius. So we will find the distance between the center of the circle, 3, 6, and 11, 12, or any of the point P, Q, R would be fine. So square root of 11 minus 3 squared is 64, and square root of 12 minus 6 squared is 36, and we get that the distance is 10. Therefore, the equation of the circle is x minus 3 squared plus y minus 6 squared equals to 100. And that's the end of chapter 6. You can check out my channel for more revision videos.